Good afternoon, and if you're joining us for the first time during the second half of the workshop series, welcome to the third International Multidisciplinary Information Technology and Engineering Conference, IMITEC, workshop series, day one. We'll be having two workshops in this last part of the session. And right now, we are going to jump into workshop 2. May I just get a confirmation if Dr. Water is ready so that I can get things started?
I'm ready. Thank you.
Thank you. Once again, ladies and gentlemen, welcome to our workshop number 2 for this workshop series we are having for the conference. We just completed workshop 1 before lunch break, and it was really packed and more than necessary to have extended and really cut short your lunch hour with extra more minutes. Without really taking much time, workshop 2 is titled Towards Statistical Thinking and Data Science. And we slotted it to run from 13:30 to 15:05, as indicated on the time slot. And our facilitator is Dr. Albert Water from Soplate University, South Africa. I hope I'm pronouncing the names correctly. If not, please just forgive me, but I'm trying my level best, that I can assure you. Right, before I give the floor to Dr. Water, I'm just going to formally introduce him. But before I introduce him, I would just want to personally say congratulations. I know you recently obtained your PhD, and we are really happy for such an achievement on your side. So Dr. Albert Water recently obtained his PhD in statistics from the University of the Witwatersrand, South Africa, and is currently employed as a statistics lecturer at Soplate University, South Africa. He also holds a master's degree in statistics from the University of Zimbabwe, and formerly he worked at the African Leadership Academy in Johannesburg, South Africa, as a mathematics and statistics faculty. He also worked at Tobacco Processors Zimbabwe and British American Tobacco, where he held various positions as a statistician, quality assurance manager, production manager, and logistics and warehouse manager. His research interests are in the fields of statistical modeling, machine learning, deep learning, and causal inference. With this short bio that I've just shared with you, of course, I know there is more that has been shared with you. You are in for a treat. I give the floor to Dr. Albert Water. Over to you.
Thank you so much. Thank you for the welcome and the introduction. Can you allow me to share my screen? Okay. Can you see my screen?
Yes, I confirm I can see your screen.
Okay. So I'm going to present workshop number 2 titled Towards Statistical Thinking and Data Science. Unfortunately, I don't know what's happening with my video. It's on, but I can see that there's a blank screen. I don't know what's happening. My name is Dr. Albert Water, as has been mentioned, and I'm from Soplate University in South Africa. Some of the examples that I'll draw from my experience as an industry quality assurance practitioner, as well as a statistics lecturer, and also through my journey during my PhD, what I've learned towards integrating statistical thinking and data science. So just a little bit of history. We all know that statistics may have its origins. In fact, statistics had its origins in census counts, which were taken thousands of years ago. It was discovered or as a distinct scientific disciplines, although mathematicians want to treat statistics as part of applied mathematics, and that is debatable. In 1791, Sir John Sinclair introduced the term statistics into English in his statistical accounts of Scotland. And also computational science, most of you here are computer scientists, began to be established as a distinct academic discipline in the 1950s and early 1960s. So we're going to see how these two disciplines, computational science, statistical science, can work together. So what have we learned since the first time statistics was used to count censuses? We have learned good data analysis, where we apply simple application of a statistics recipe, and we say that's good. Also, we have learned good data analysis through simple application of statistical software. You hear people talking about S+, SPSS, SAS. These are some of the most popular software that have been used in statistics, and people have actually achieved good data analysis using this software. So we've learned a lot. But what does learning statistics today entail? I saw a lineup of a number of conference papers that will be presented, and most of them, I'm sure they've used statistics here, and some of them they've had to learn statistics from the first time in order for them to achieve their analysis. But what does it entail to learn statistics today? It has come a long way from just learning from the application of recipes. But I say but because even if it has come a long way from the application of recipes, we must consider within the domain of statistics typical instructional practices in the field. So there are certain things that we must also take into consideration in the statistics paradigm. But what has really changed? I'll use an example of canned data from the experience as a statistics lecturer. Normally, we give students data and we say, okay, analyze this data. It's like a can, you open, you hit, and you save. So what do we do with this canned data, like data in a can, data that has already been prepared, data that was collected elsewhere by someone, cleaned, and everything was done. So one, you learn a method, you are given a data set. Two, you prepare your analysis. So it's like a can, you open a can, you hit, and you save. But things are changing. What we need to focus more is on collecting your own data. I'm sure in any analysis that you want to do, the question of data is very important, and it comes into play. What is your data? The first question that one asks you is, what is your data? So you must have time, let me just move this, time to engage in projects that solidify a concept through collecting your own data. You can also find big data online because big data is a lot of challenges. So if you find that big data, there's a lot that you need to do in terms of cleaning the data, dimension reduction, making it in a form that is applicable for the type of analysis that you want to carry out. So you can find a large data set, e.g., for example, data collected for an administrative purpose. The data is big, it's nearly everyone, so we assume that it must be right. And then what has also changed is that more and more focus is now put on exploratory data analysis and visualization. I'm glad the previous speaker, Dr. Yuan, spoke a lot about visualization, and it is becoming more and more prominent. But during the course of the statistics learning, statistics journey, in terms of maybe teaching statistics, the statistical practitioners would think that EDA is for babies. They are grown-ups. They want to talk more about theorems, Poisson distribution, normal distribution. They want to talk about proof of propositions, proof of lemmas, and so on. But EDA is no longer for babies, is now having great prominence in the journey towards statistical thinking and data science. So how do you then start to think towards statistical thinking and also incorporating a bit of data science? You can start by the code that was presented this morning by Dr. Yuan, how he was explaining it. Get that code as a template, follow the steps. As you can see, sometimes the steps may not be easy to follow, as you can see from the diagram. But what is important is, despite this pattern of steps, can you therefore have a blink on reproducibility in all these steps? Or you can't quite remember all the steps to get to the end of the results? I'll touch more on reproducibility and how we can infuse that in our statistical thinking later on. So, when you're solving a statistical problem, context matters. The important difficulties and the whole point of statistics lies in the interplay between context and the statistics. Every time the amount of data increases by a factor of 10, we should totally rethink how we analyze it, said Friedman in 1997. So whilst you are also thinking of a statistical problem, you must also think about the computational context. So you must also move towards more computational statistics as well. And you start to ask yourself inferential questions that are informed by and defined by computational considerations. Now, what suggestions are there for one to start thinking or improving our statistical thinking? So one can try open-ended problems with context. You can start to begin to experience the complete data analysis process, which includes the acquisition. You must also be conversant on how to collect your own data, its preparation, transformation of the raw data. And as you move towards statistical thinking, you must also try to conduct modern EDA, which is exploratory data analysis with visualizations throughout the data analysis process, and also emphasize more on core computational paradigms. And also, the most important is to free statistical theory from normal theory. I'm sure those who are familiar with statistics, the normal distribution is said to be the most important distribution, and along its cousin, the central limit theory, which says as long as your n is large, you can approximate that distribution using a normal distribution. So you can almost use the normal distribution anyway. But let's free, as you move towards statistical thinking and data science, what is there in data science? Data science, they start talking about employing the test train paradigm or the train test paradigm. Now, in your statistical thinking, when we start freeing ourselves from the normal theory, and we also think in the train test paradigm, we are in a way moving towards statistical thinking and data science. I'm sure in this house, there are a lot of data scientists. The train test, sometimes train test validate are common techniques that are used when they are evaluating their models. But in statistics, some of them might not have seen much traction because one is a set of data, does this logistic regression or linear regression, does complicated stuff. But have you ever thought about employing some of these paradigms? So what am I saying? Infusing statistics with data science makes you a better statistician or data scientist, or vice versa. Infusing data science with statistics also makes you a better statistician or a better data scientist. But how do we do this? You must begin maybe to look at full case studies with data access, cleaning, and transformation. You go through the cycle of exploration, you critique and compose visualization, you ask yourself questions, is this the right visualization for the type of data? Most importantly, you must put the 3 R's into theoretical statistics. The 3 R's of data science are repeatability, reproducibility, and replicability. During my time in industry, when I was working for the tobacco industry, we as a quality assurance analyst, manager, and so on, we used to dwell more on repeatability and reproducibility, because customers would come with certain specifications for, am I talking about the tobacco industry, to say, I want you to pack my tobacco with a certain value or certain specification of the nicotine and sugars. But then how do you prepare yourself? How do you prepare your equipment? So we used to do a lot of repeatability studies where we have a single operator, and then he performs repeated experiments using the same samples drawn from the same sample, and then we check for variation. During our time, we used to say the customer does not experience the average. Customer doesn't experience the average nicotine level, and you say, because my average is this, then it's good. The customer actually experiences the variation. So I can give an example of a drink. So maybe your favorite drink is Coca-Cola. You don't experience the average volume of 500 milliliters in it, but you experience the variation in the test. So the variation in the test could be as a result of certain targets for certain chemicals that are in that Coca-Cola not being met. But if you prepare yourself, you do this repeatability, you reduce variation, and then you know that within certain specific specifications, you know that your product will conform. But also these concepts are also used in data science. Reproducibility. Can someone take your code, get the same results as you have obtained? So we are moving towards, we can also move towards, okay, how can someone reproduce your work? Then it opens up collaboration, and it opens up a lot of things. Okay. So what does the data analysis entail? So it is important to see the raw data now. Try to get the raw data. Don't just go and say, data in a can, I can get data somewhere as you do your research. Try to get empirical data and understand the steps in the processing pipeline. How do you process your data? When you do that, you begin to incorporate hidden sources of variability in your data analysis, and you start to understand your data better. So it is critical to include the rawest data that you have access to in your analysis. I've heard people say for a data scientist, 80% of the time is spent cleaning or preparing the data, and 20% is spent on the actual analysis. So they use the 80-20 rule. In some circles, they call it the Pareto rule. So someone has said, I spend more than half my time integrating, cleansing, and transforming data. Most of the time, once you transform the data, the insights can be scarily obvious. So once you play with the data, you realize you made an assumption that is completely wrong. It's really useful. It's not just a waste of time. So try to love data, try to play with it, try to see how you can collect your own data. In practice, it tends not to be just data assumptions you can make about the data or about data exploration that I'm talking about. You can reinforce EDA as a habit of mind. Be prepared for surprises. What you thought about the data may not what comes out from the EDA. You must be creative in terms of your visualizations. And I'm sure Johan gave you a lot of tips. And I'll also go through a practical with you, but this time I'll be using R. Johan used Python. We'll just do a small practical to see how we can do EDA, play around with it and create some visualizations with the data. How do you then construct statistical understanding? You must use computing expressively to simulate, resample. You might have a certain data, but when you start simulating your own data, generating your own data based on a certain set of data that you have, and then you begin to understand, to create or construct statistical understanding. But during my PhD journey, I did a study on statistical methods and deep learning machine learning methods in causal inference. I actually saw that data science integrates computational and statistical thinking. How? Because these two fields, statistical, computational and statistical thinking, they all try to solve authentic problems in the scientific context. They work closely with original data. They also use computing expressively to conduct analysis, construct understanding, reproduce and replicate. They also use data technologies, statistical thinking, programming. Also, there's the use of existing software rather than build routines from the ground up. So you can take advantage of software that is already there, and then you can model how to learn new technologies. So in a way, data science, because of the fellow integrates computational and statistical thinking, because they all share similar philosophy and goals. What are statistical concepts that are key, that have also key for both statistical thinking and as well as data science? An understanding of statistical variability, data reduction, method of comparison. How do you compare methods? In statistics, we have methods that we use for comparing methods, as well as in data science, you have your evaluation methodology, you have metrics that you use, and also statistical concepts. We incorporate a lot of graphics, elements and principles of graphing. We use a lot of simulation tools, Monte Carlo, Bootstrap, which is also part of resampling. And then we can also, we can also, during model assessment, incorporate the train, test, and cross-validation technique. So we'll see in the practical how we can do this. So what are the synergies between statistical and computational thinking? They all evolve around EDA and data wrangling. And it's good that the first speaker or the first workshop was more on visualization, which is also a key aspect that is driving synergies between statistical and computational thinking. So EDA in the modern era requires computational skills, and also data wrangling skills offer capability and flexibility to perform EDA. So what is the main goal of EDA? It can inform data wrangling and also inform data analysis. Probability and abstraction. Simulation studies require abstraction and algorithmic thinking. What does abstraction help us with? It helps us to develop probability models for our data, compare variability in our data statistics to benchmarks, check appropriateness of our assumptions, as well as resembling model methods and algorithmic thinking, which serve to move simple physical demonstrations to applications to real-world phenomena. If you perform resampling, it can also highlight the essential aspects of the testing. Modern methods can also be employed. Bootstrap, test, train can be conveyed through algorithmic thinking. Most importantly, reproducibility and communication and collaboration. Communication skills are broadened through publishing code and pseudocode. I'm not sure if we do an audit of all the papers that are coming down there, how many have actually published their code and also at least attempted to put a pseudocode. So if you're not in that practice, you can start publishing your code. What it does is that reproducibility relies on publishing code, data, and metadata. And this can also assist in collaborative aspects of project development. So yeah, reproducibility is very important for both statistical thinking and data science. So what do you gain from what I've said? What do you gain? Like what did I also gain when I took a journey of trying to infuse statistics and data science? I also had the exposure to statistical thinking in a different environment. That environment was the data science environment, and the way I brought my statistical thinking and also learned from data science to enhance my statistical thinking was amazing. I also gained technical skills to engage in collaborative problem solving, and you can also gain confidence to overcome computational challenges to carry out a comprehensive data analysis and not say, no, I'll find a consultant or someone can do my analysis, or when it comes to analysis, you start shivering. No, you become more confident. And also the ability to communicate through writing code as well as writing reports. You gain a lot through that when you can start to write your paper, write your code, communicate your code, and then you become more confident. Okay, so at this stage, I'm not sure what format was used, or do questions come at the end, or I can just go to my case study and then I'll entertain questions later, or I can entertain questions now and then we go to the case study. I'm not sure how it was going with the other speakers.
I'll leave that open to you. If you'd want to engage your participants as you go along, that is actually also welcome, so that at least we also break up the silence.
Okay. All right. Are there any questions to any of the issues that I've raised? Or anything coming from the discussion? Do you have any question? Okay. Looks like maybe questions will come at the end. So what I'm going to do, I'll continue. Okay, there's a question.
There's a hand.
There's a hand up.
Yes.
Yes, Dr. Wata. Dr. Wata.
Yes, you can go ahead.
Yeah, mine is actually a question that is taken from the previous speaker into your presentation, where you are saying computational thinking is what do I want to say? I'm just thinking about how the computational aspect fits into your statistical thinking and how it comes into the story, whether it's coming from birth, growing into the story, or it's something that is thrown in the middle and then happens to just exist there in the middle of the story. Are we going towards statistical thinking, or we are moving away from statistical thinking into computational thinking? Or are you saying these guys are moving parallel to each other? That's my question, sir.
Okay, thank you. If you remember, there was a slide where I said, and then I shared a couple of complicated equations there. That's how statistics has been viewed. People try to look at the complexity of equations, proving theories, theorems, lemmas, and so on. But little attention is then put on the computational aspects, which we are saying when you start incorporating computational aspects, you are moving towards more of the statistical thinking as regards to this theoretical domain where you're just trying to show your prowess in terms of proofs and so on. But then when you move to that computational domain, you are also creating synergies with another computationally heavy domain, which is the data science domain. I don't know whether I've answered your question.
Yeah, Doc. Yes, I get the picture. You can proceed, sir.
Okay. Another question? So I'm just going to describe the case study that we're going to do, and then I want to share and go to my R, where we can play around with data. So the case study is based upon the data science life cycle. Now, this data science life cycle is the one that we said, if you want to move more towards this statistical thinking, you can start incorporating this also data science life cycle. And also when you infuse the two, statistics and the data science life cycle, you benefit either way, you benefit. So the data science life cycle starts with the context, the question, where you look at the question, what do you want to solve? And then you go on, you can even refine your question to one that is answerable with data. And then you create your design. Remember this data science life cycle, for those who are familiar with the definition of statistics, where people say it is the science, some say it's the art, but it is the science of collecting, representing, analyzing, and making conclusions about the data. So there are similarities here. So you also move on to the design, which is the data collection, data cleaning, but we also use the test, train, split. At this point in statistics, normally you have this data, you want to perform a regression analysis, you just use the data as it is, but few would actually say, okay, let me just split my data into two and have only a training data set. And from that training data set, I can build my models, and then I'll test my linear regression model. I'm not talking about any machine learning model, a simple linear regression model, and see how it performs on a test data set. These are things that most data scientists are familiar with. They do their testing 80%, 20%, whatever percentage ratio they use. And then you can also, so after your data cleaning, data collection, at that point, you can do your test, train, split, whether you're a statistician, data scientist. So if statisticians can actually start incorporating that as well, that would be awesome. And some are already doing it. I'm not saying it's not been done. I'm not saying it's novel, but I'm just emphasizing the need for it. You also go to modeling, where you look at the loss function choice, feature engineering. Is there a need to transform my variables? Can I create dummy variables? And can I use model selection? Model selection, if you're coming from the statistical side, I mean, let's say you're performing multiple regression, you can then say, let me perform stepwise regression, add a variable, look at the effect it has on the standard error or on the R squared or whatever you are looking at. But can I also use techniques such as cross-validation in statistics and then tune my model and see over so many folds, how is the loss function performing? Okay, so that's the data life cycle that we'll look at. So a few notes on the approach include the question refinement, refining the problem statement, your question, what do you want to answer? Visualization to clean the data. What is the connection between, say, something like regression and supervised learning? Can you perform the test, train, split before EDA? Can you solve multivariate problems? Can you have a physical model and then versus a statistical model? And also, what sort of model fitting can you do? Model fitting as an optimization problem, because you know most of the machine learning, deep learning algorithms, they perform optimization. They are principled on the on optimization. When you are doing a classification, that's a maximization. When you are looking at the loss function, you are trying to do a minimization problem. Can you then look at alternative loss functions? Can you also do feature engineering and also perform interpretability of the coefficients, do inference and prediction? Can we also start employing or continue employing cross-validation for model selection when we are actually in the statistics paradigm? And then how do we assess our models and so on? Okay, let me stop sharing. And then I will share my practical. I hope I'm still on time. Okay. Can you confirm if you can see my screen? Okay, someone says sharp. So I'm going to walk you through, it's a common case study, or it might not be common to some. This case study is premised upon donkeys in Kenya. You know, donkeys in Kenya are considered to be very, very important, and they actually take good care of them. So this case study is trying to look at certain variables that we can measure from a donkey, and then try to do some analysis. I will not be explaining every line of code, but I'll just explain the chunks. So I'm using R Markdown, which is in R, and obviously there are certain packages that you need to install. So after installing the data, you need to read the data, those who are familiar with R, or you can use any environment. You can use your Python environment. So what do we want to do? We want to use donkeys in Kenya, and we want to predict a donkey's weight based on other easier to collect measurements. Our focus here is on EDA, exploratory data analysis. Obviously, when you have collected your data, you go and measure the variables that I will explain below about a donkey, and then you have collected your data. You might be interested in doing a little bit of exploration of the data. The first thing that you want to do in your data is how many observations do I have? How many variables are there? So you do the dimension, donkeys, and so on. In a data set, whether it is collected by you or you are given a data set, you also must be interested in seeing what sort of variables are there. As you can see, this data set that I'm using is variables such as BCS, age, sex, length, girth, height, weight, which I will explain below what each one of these means. But I also need to do, I'm still exploring my data. What if I do summary of the variables? You see BCS, it is the minimum, maximum, age. Age is a factor, or it's a categorical variable, so it doesn't have those minimum, maximum. But if I look at numerical variables like BCS, length, weight, height, and girth, there's something that you can actually start seeing here. There's a minimum value that is actually, if you look at it, it's way below the median. So you start raising certain questions about that value, but you don't know yet. So you do further exploratory analysis to see what's really happening with that value. So we want to explore the distributions of each variable, and you can also recall, and I can also explain what those variable means. So BCS is the body condition score, which should range from 1, it's an emaciated donkey, to 5, it's an obese, and these are in half unit measurements. And then there's age, under 2 years, under 2 months, 2 to 5 months, 5 to 10, and so on. And then there's the sex, which represents whether it's a stallion, a gelding, and a female. There are other variables that we can also, as you can see from the screen. But before we examine the data, we want to determine what kind of variable each one is. So we'll do, okay, so what we can actually do is the following, where we can do str, this is in R, donkeys, and then we can run our code. So when we run our code, it tells us what sort of variables they are. As you can see, BCS is a numerical variable, age is a character or a factor variable, sex is also a character or a factor variable, length, girth, height, these are all numerical variables. And also I've performed a count of BCS to say those that have a BCS of 1.0, how many are they? 1.5, there are 5, and so on. So I'm trying to get an understanding of my data. And then I can go on and say, okay, how can I better see, instead of just looking at in a table like this, can I just do a simple chart to see the distribution of the BCS? I'm sure in the morning session, you also had very beautiful charts using matplotlib. ARA is also another beautiful package, which is ggplot2. It also produces very good plots. As you can see from the table, the bar plot, roughly 2/3 of the donkeys are in relatively good condition. But we are worried there's a donkey which is at BCS 1 and another one which is at 4. This could be outliers or even greater than 4. So these ones could be outliers. Greater than 4, it could be an obese donkey. Somewhere close to 1 could be a small donkey, could be a baby, or it could be a donkey that is emaciated or not feeling well, ill, or so and so forth. You can also do check the count for the age, and also do exploratory on the age variable and see what's happening. And you see, oh, most of the donkeys are aged between 10 and 15. You're now getting to get an idea of the data. And you can say roughly half of the donkeys are 10 to 15, okay, these were in years, 10 to 15 years old, with the remaining spread evenly about over the intervals 3, less than 3, 2 to 5, and so on. You can do the same for the variable sex, and so on. But then there are variables that are quantitative here, like the length, girth, and height. I'll just remind you again, if I run summary, you see that the BCS, length, height, these are all numeric variables. They give you minimum, first quarter, median, mean, upper quartile, and also the maximum value. So let's look at that donkey that, you see, if you look at the summary, there's this donkey which has minimum BS of 1, minimum length 46. We need to get an understanding of this. So let me say, what if I filter and only look at donkeys that have a length of 46? You can even filter by weight and see, I want to see all those donkeys that have a weight less than 28. Remember, we are doing EDA, so don't forget what we are focusing on. And you see now, if you see that it is a length of 46, the girth is 66, 71, and it appears as if it's the same donkey here that we're talking about, which has a minimum girth of 66, height of 71, and weight of 27. So you can start telling a story here and say, oh, this could be the same donkey, and maybe it appears to be a baby. And then we want to drop that donkey, and we also want to drop an obese donkey and maybe work. So in other words, what I'm trying to drive it is, in your data set, there could be some outliers, which you may also want to remove. So I can drop some outliers, and then after that, I've done a bit of cleaning. But what is more important here, if I were analyzing it from a statistical perspective, I'll just go with the data, bring in my fancy statistical models. But now I'm trying to introduce the setting aside a test set and say, let me split my data, like what the data scientists do. They split 80-20, and I'm also going to split 80-20. Can I make my code reproducible And you see here, I've put set.seed. You can put any number there if you want to generate a code that is reproducible. So I've now infused, so it's now infused my statistical thinking and also used the data science paradigm. By statistical thinking, I'm saying, how do I then, when you start analyzing your data, telling a story about the data, that also forms part of your statistical thinking. But when I'm also using the train test split, I'm also going towards data science rather than do the usual regular statistical analysis. I hope you get my point. And then if I run this, let me run it, otherwise there's a ripple effect done there. I've already split now my data into 80-20%. Now I'm going to work with the training data set, build my models using the training data set, and then I'll see how I'm going to then validate my model using the test data set. So I can create some histograms for those numeric variables. I've already done that, so I've already created the code. So let me look at the first one. I hope it's clear, but there's something funny about this graph. It looks like it's skewed to the left, right? So this also highlights the importance of EDA. Don't just jump straight to analysis. Look at your data. Does my data, is it approximately bell-shaped? I mean, this is the usual, normal that we want. Is it? So can I perform some transformations here? Will I get reliable results with such data? Let me look at the next variable. So this one was length. Let me look at the next one, which is girth. Again, is skewed to the left. And this one as well is also skewed to the left. So all three distributions, they show a skew to the left, that is towards more smaller donkeys. The medians being larger than the means confirm this. If we go back to the summary bracket donkeys, but the difference between them is small. Also, we see that there's a very small value in each of the histogram. So the skewed distributions might suggest to you that you might also want to do some transformations of variables because symmetric distributions behave better in our formal analysis. So let me look at weight and the other variable, which is weight alternative or weight out. So if I look at the weight, what does the histogram look like? Okay, that's skewed to the left. Again, we find a distribution that is skewed to the left. We also examine the weight out variable. Is it identical to weight? Let's see. So if I look at the weight out, I've got a different picture here. The weight out values are very close to the weight values for these 31 donkeys. So this histogram tells us that measurements process for weight is accurate to 1 kg, and there's no need to weigh donkeys multiple times. Now, okay, we have done exploratory, you have got your data. Most of you are familiar with things like correlation analysis. You want to see if there are any relationships between your variables. So you can start looking at what are called bivariate summaries to see if you can get any meaningful correlations between. So the code that I'm just using there is pairs, donkeys, and then let's see what we get. When you do that, you get a beautiful plot, which actually shows you the relationship between either weight and length, weight and gain. So the one at the top is your control variable, so that's your weight. So when you go down, the first plot that you see, weight and gain, fortunately, I don't have a highlighter there. But if you look at the weight and the girth, which is the graph on the third box from the left, that is more linear. So you can start telling a story and say, what is the relationship amongst my variables? Is it a positive linear relationship, negative linear relationship? And then you can start having the correlation in mind. And then if you want to look at the strength of the relationships, you can also go on and do some correlation analysis And the correlation analysis is also confirming that the weight and the girth, they have a correlation of 0.8987, which is close to 1. And we say there's a strong positive correlation. Can we therefore say that the single best predictor, remember we want to predict the weight. Remember our story, our question. The weight is the one that we want to predict. So can we therefore say the single best predictor of weight is girth of the donkey? It appears that height is the least correlated. If you look at height, so it appears that height is the least with girth. So height and girth, you have 0.697, but we would need to perform a more formal analysis of all two variable predictors of weight to confirm this. So how do we do that? So let's take a closer look at the relationship between weight and girth. So it's a positive relationship, and we have also seen that the correlation is high. We can also examine the relationship between length and girth. You see, it's not as strong as the one between weight and girth. You see, if you compare these two graphs, you see the other one is more, it's more scattered in a way, if I want to use that term. So in addition to the quantitative variable, we can also examine the relationship between our weight and the categorical variables. And you must choose an appropriate technique to do that. And one of the graphs that is very good at doing that is the box plot. So we can actually draw a box plot of the weight and a categorical value such as sex. And let's see what we get. Oh, this is what we are getting. And if you see that, if you look at the weight in comparison to the different sex of the donkey, you see that there appears to be more variation in the weight of the females. And the least variation appears to be in the gelding. So you see the box is a bit narrow. So those, when you have a box plot like this, it means your interquartile range is small. And when it's smaller than the other ones, then there's less dispersion or less variation in the weights of girth. So these three groups have a similar median. The interquartile range for geldings is small in comparison to others. The geldings may tend to weigh more and be less variable. Again, you see that their median, which is represented by the horizontal black line, is above that of the female and the stallion. Again, we are making a story, and a good story out of that and out of exploratory data analysis. You also, what are the implications? We can create an indicator variable that indicates whether the donkey is a gelding or not, and use this in our analysis. So I've just created one. And then next we can examine the distribution of weight for the various body conditions. To do this, remember BCS is body condition of a donkey. So you can see how that one varies with the weight. Again, you can see that as the BCS increases, the weight also increases. As the body condition of a donkey increases, its weight also increases. So the implication is that the weight distribution appears to be shifting upward for each category. Excuse my typing, I was typing in. Appears to be shifting upward for each category of body condition. So we most likely want to use body condition as a variable and do not want to collapse categories. Sometimes if these box plots, some of them are at the same level, there's no point of using them as different categories. You can just collapse them into one. But here, there's quite a clear picture that they are shifting upwards. So you might want to use the BCS as separate variables. So we can also examine the weight distribution for the age distribution. Again, this one tells us this story. It's no longer as shifting upwards as the one for BCS. And what story can we tell out of this? we can say that the orders of all age groups are mixed up. As you can see, that's something that it happens a lot, but you can fix it in R. So you can actually write a code to fix that. And then you make your plot again. And then when you make your plot again, you see now that the age is properly arranged. So that's one thing that you should look at. When you do exploratory, sometimes these packages, they behave in a funny way. And then you might make a wrong conclusion without carefully analyzing your plots. So if you look at here, the last 3 box plots, that is from 10 to 15, 15 to 20, there doesn't appear to be any meaningful differences here. So we can now see that there's not a big difference in weights for donkeys over 10. That is the 10 to 15 group, 15 to 20, and over 20 categories have similar quartiles. So the implication of this is you may want to collapse the age groups for 10 to 15, 15 to 20, and greater than 20 into one group of donkeys and just call it over 10. And then we can create a new variable so that we keep the original variable in these categories. One thing that you must always do, keep your originals. Otherwise, if you mess up your data and you want to go back to the original, you've already transformed it. Sometimes it's painful, you may have to start again. So you create another variable, and here I called it age 2, where I've collapsed those that appear to be the same. Okay. Now, if you look at I don't know if you remember the scatter plots, but I don't want to go back in the interest of time, but I'll just explain. The scatter plots looked a bit elliptical. They didn't seem to have any need for transformations. But what about if we to transform one of the variables and then do an analysis, or maybe do a correlation analysis and see what is the impact? So I'll look at Geth, and then I'm going to square Geth transformation. You can either square, or you can take log, or you can take square root. There are so many transformations that we can use depending on your data. So if I do that and then plot a histogram, so, and then the histogram does appear somewhat improved, but let me look at the correlation. The correlation is 0.87. Remember, weight and Geth I had 0.8987 before. Now it's just gone down to 0.8786. So the implication is that whether or not there's an improvement here it sounds debatable, but I don't see whether it was necessary to do this transformation. So we don't necessarily want to make our decision based only on correlations. So let's leave the variables untransformed for now, and then develop our techniques further and see what other methods we can use for basing our decisions on. So we can now do model fitting. Here, there's no machine learning aspect here. It's just a simple linear regression model, multiple regression model that is fit here. If I fit this model, and then in order to see the output, I can just call the summary lim.all. So I'm doing a regression, multiple regression of weight, and my regressors are height, Geth, length, age, and so on. The statisticians now, what the statisticians will do, they will come here and then say, okay, which one has a p-value less than 0.05? So that one is significant, so we need that. And then those that have a p-value greater than 0.05, they are usually checked out and say, no, they are not necessary. But is there another way in which we can choose a method, the best parsimonious model, meaning we want to choose a model which has as much predictive power, but which uses less regressors? Can we do that using the cross-validation technique that is so prevalent in data science, machine learning? So we would like to fit the simplest possible model that still has good predictive properties without necessarily having to look at the coefficients, the p-value. Can I use another technique? Yes, I can. So I can actually employ the package E1071, which is a package that can also perform cross-validations. And I can also start by saying, what if I create a model that only has the weight and girth? What about the one that is weight, girth, and length, and so on? So if I run this model using tenfold cross-validation, and as the error estimation of the linear model is my evaluation metric, I see that here I'm going to choose the model which has the least error, and this one is the third model, the one that contains girth, length, plus height. So I've also used cross-validation, and I've run away from this table, which might be complicated for some of you if you don't even understand what p-value means or what it is. So the two variable, but if you look at the two variable model, girth and length, its error is 86.308. The one that is girth, length, and height, its error is 84.82. There isn't much difference. But in the principle of parsimony, I think I have to go with the one that is the least number of variables. So the two variable model greatly improves the one variable model from an error of 122 to 0.94 to an error of 86.308. And you can see that the difference between the second and the third model appears to be small. So let's stick with the two variable model and consider maybe adding some more categorical variables. So I'll just look at models that I've added sex, age, BCS, we changed it to a categorical variable as well. And let's see what happens. If you see here, I think the least model, the model with the least error is the one that is girth, length, BCS, age 2. So notice that BCS is the single best factor to add to a model. Also, if I add BCS, the models that have BCS have lower error, as you can see. So BCS also alongside age as well are the best factors to add to this model. So also notice that age in the presence of BCS improves model. So all this, what I'm doing here, you'll be just exploring, trying to see what is the best model. So that's the morale of this story I'm telling you here. You may also want to do model assessment. Now that we've selected our model, we can proceed to assess it with the test data. Don't forget, all that we've been doing, we've been working on the training data set. Now, how do our models perform on data that it has not seen before, which might be lacking in some of the statistical analysis where people can just run and then on training data, it might be performing very well. But on a data that it has not seen before, the method might actually fail. And those who do a lot of machine learning can attest to this, that it can actually give you headache sometimes where you need to optimize your model and get sensible metrics like classification, AUC, depending on what you're looking at. Okay, so now that we have selected our model, we can proceed to assess it with the test data that we set aside. We must first prepare the test set. Recall that we converted BCS and age into factors and we collapsed some of the categories of age. We can also do that now. So you do what we have also done before, because you want to compare apples with apples. I mean, you cannot compare something that is not transformed or collapsed to something that is variable that are collapsed. So you keep that in mind. So we do that here, and then we can fit. Now we fit our model on train, set, and save the return value. Remember, we chose a model. Oh, I do not explain this. Our choice now will choose the model that is girth, length, BCS, and age, because it had the least error there. So that's the model that I'm going to use it on test data. So I can run that. So let's see. Okay, where am I? Now we fit our model on our train set and save the return value to use for prediction These are things that machine learning data scientists, they also do when you do your confusion matrix and also all those things. So I've trained now on the, first I train on the training data, and then I use my, and next we predict the weights of the donkeys in the test set using the fitted model. And then we can plot the predictions against the actual weights to see how well we did. So we can plot and see how well we did. So let's see if our plots can work. Yes. What the model is telling us here, I will just explain. It is telling that our predictions are nearly entirely within 10% of the true weight, because we fixed the slope to be 0.9 and 1.1. And then you can see that almost all they are within 10% of the true weight. I think, ladies and gentlemen, this is a good point to stop. We have gone through in exploratory data analysis. We have seen areas where we can actually infuse the data science paradigm into the statistical thinking without even using any machine learning model here to say fit this, fit dot whatever model and so on. I think I've come to the end of my presentation, and I can entertain some questions. Thank you. Over to you, Chair.
Okay, thank you, Dr. Watt. I think Dr. Gamundani, Dr. Gamundani, in?
Yes, I'm in. You can take over the interaction session and wrapping up this one.
Okay, thank you, Doc. Let me be watching the chat. If there are any questions that have been posted here, so far we don't have any. Do you have any questions to pose to Dr. Watt? Or there's a hand. Mr. Sila can go ahead.
Maybe Julius, maybe your mic is muted if you're trying to speak, because we can't hear you.
Mr. Sila. Okay,
Can I jump in while Mr. Sila tries to unmute himself?
Yeah, sure. I can go in, Dr. Shibai.
Me, I'm coming from an old school man, right? Those who started seeing these computers in the 1980s. Right. And I'm thinking, what really is new in this story? Did we not see these things in SuperCalc? For those who know what I'm talking about, in Lotus 1, 2, 3, in Quattro Pros, were we not seeing the very same things? What's the big deal now that we are having workshops on things that we have seen 20 years ago? What's new in this story? That's my question.
Dr. Shibai, can you specify exactly what you have seen? Then I may be able to, because I've not seen Quattro or what.
So exactly the story. You see, this story is the same as what we even see in programming languages as well. That we have new programming languages, we have Javas and all these C++, but they were old languages that did exactly the same. And all what happened was a change of name, and then they became new things. We are looking at R now, and the illustrations, the beautiful illustrations that I saw in your presentations, are things that I might have seen in other packages that existed long back why was there something like Lotus 1, 2, 3? What was the 1, 2, 3 about? It was all about achieving all these analyses, visualization. So what are these new packages really bringing on the table that is different from what we knew from before?
Okay.
Dr.
Shbaya,
other than
yes.
change of name.
Yes, the focus was not on the package per se, on R, but it was on the thinking behind that. I could have done the same in C++, I could have done the same in Patroco, in Lotus, but the thinking there of saying, in the data science paradigm, we do some cross validations, we do some train trace split, we do a lot of computational. Why can't we bring those things? I know they are there, and then bring them out more into prominence in the statistical field. And then remember the example I gave about EDA is for babies, and then theory and all those are for grown-ups. Can we therefore start focusing and also giving more attention to EDA? I can tell you a story, Dr. Shbaya, is most lecturers, if you those who teach statistics, or even if you attend a statistical course and they are doing EDA, what you learn from there is how to do a histogram, how to do a scatter plot, and how to do that, and it ends there. So what more can we do? I mean, in terms of enhancing and being more creative about EDA, there should be more focus. I'm talking about in the statistical paradigm. I know in data science they can even have a course where they just call data visualization and they go a bit deeper, which unlike in the statistical thinking, statistical realm, those are things I just say to be, I know they're not even taken to be that serious. No, let's just do a histogram. This is how you represent your data. Let's focus more on the deeper stuff. But now we are saying, we are shifting and say those EDAs should also have much prominence as your heavily theoretical undergrounds or pinnings. Yes, Dr. Shbaya.
I get you. I guess there are some chats on the side. I saw some chats popping up and questioning my question as well. But thank you, sir.
Okay, thank you, Dr. Shbaya. Dr. Watt, I've got a question here, actually 2 questions or more. The first one comes from Deshi. She says, or I'm not so sure, he or she says, when there are no relationships between the independent variables, can one still use linear regression? Why didn't you use multiple linear regression since you have more than one Y variable? Dr. Wata, maybe you can answer to that.
Yes, I think it's still possible when there's no relationship between the independent. Yes, one can still use linear regression. Yes, because that correlation does not mean that you can't. You can also use linear regression there. Why didn't you use multiple linear regressions since you have more than one Y variable? I think the Y variable that I was concentrating on was the weight. So I had one Y variable, which is the weight, and the rest were my regressors, were independent variables.
Okay, thank you for answering that. We'll check if there are any follow-up questions. I've got another one from Mr. Leo Marwasa. He says, but in what format did they exist and what level could you visualize? Even the program language, maybe it was programming language constructs that were available then, it would take more code and more steps to achieve what we can achieve in a few lines of code. I think this partially answers Dr. Shbaya's question. Maybe
it doesn't answer me. What happens is we do have black box programming today. And if you want to go white box, if you open up that black box, those LMs and whatever you have, there will be longer lines of code. All we are saying is all these used to develop things from the first principles without using hidden abstracted codes. So we can say there were more lines of code, but we had open white box coding than the black box coding that we are talking about today. So lines of codes, it's still the same. There is no way you can skip a process today rather than using a library. Using a library simply means you do still have the same number of lines of code, but they are hidden to you and you'll never know what it is. That's my argument on that.
Okay, I will leave your argument for last. Okay, the other question is from Mr. Silla. He went on to the chat. He says, how do you draw a line between your own data and data in a kern, considering that certain disciplines rely more on standard data sets or various experiments? You may want to come in, Dr. Watt.
Okay, this is a very good comment, but you know what I'm advocating? I'm not saying data in a kern is bad. It is not. But for you to understand the EDA process, you must be deliberate about trying to collect your own data. I also know that sometimes you cannot get data and you also have to simulate your own data. Sometimes you may also have to use models such as GANs, generative adversarial network, and then you generate your own data, which closely mimics. Yes, but I was only trying to encourage more of the data collection so that you understand the whole process. Because if you entirely rely on standard data sets that have already been cleaned, everything has been done for you, there's not much you do, and then you just apply your models. Sometimes you need that training in terms of exploration. I know some of the standard data sets might also do a bit of feature engineering there, variable selection. But what if you had the rawest of the rawest data? Have you had that experience? Do you have that experience? Would you like also to have that experience? What would you experience if you look at the rawest data? That is the point that I was trying to drive home. Thank you.
Okay, I'll also check if there's a follow-up question from Mr. Silla. Any other questions? Maybe as I wait for more questions, we still have time. Dr. Chibaya, I think the point here is these languages that are being talked about now, the R, the Python, they are more solution-oriented than the generic ones that we used to have, that you saw. That is the C, the C sharp, etc., etc. I'm sure that's the point that is trying to be drawn here. Oh, we have a follow-up question again from Mr. Leo. If we dig deeper into machine learning level, the number of bits a machine could handle then is far, far less than today's laptops. So information blocks we handle now are bigger. So I will say the lines of code have reduced. In industry, the focus is in the solution, not on the low-level code. You want to come in, Dr. Chibaya?
My mic is muted and mute now.
Okay.
No, it's fine. I get the arguments, but yeah. As I said, I'm just coming from an old school. You can't teach an old dog new tricks. I still believe our old way of doing things really dig deeper into us understanding what was going on than playing around on the surface and claiming to be solution oriented. Thank you.
Okay, you're welcome. Yeah, I can see the debate is heating up. I think you can also engage on the sidelines of the workshop, which is quite good that we know each other. Let me see if we have more questions.
Can I see Mr. Namo's face, please? I know that man. Can I see him? He's talking to me, but I want to see his face. Namu. Isaac Namu.
Mr. Namu Isaac. I'm not so sure if he's in the chat.
Yes, he's here.
that is not on video. His device only has audio.
Well, I
Okay.
hope you can hear.
I'll ask him to communicate with you.
No, it's fine. We are chatting. Sorry, thanks.
Ah, great, great. Maybe in the absence of any questions or contributions, let me take this opportunity to thank Dr. Albert Water for the workshop that we have just given us. The dimension that you gave us on how to analyze data using the R language. It was quite important to see how this data analysis can be applied in a social environment. I liked your workshop where you based on the donkeys in Kenya. It's quite encouraging to say we should not just analyze data that we find, the data that has been cleaned that we find in the repositories. Let's try and go out into the societies or go out in the field, collect our data, and then try and analyze it and draw some conclusions. And mostly, you also touched on the fear of analyzing data. It's quite true. You know, when you go out into the field to collect data and you come back with that data, we try to analyze it. It becomes meaningless because that data is not in some relation that we might want, and you end up discarding it and take from the internet that is already cleaned. So thank you for highlighting that. Dr. Gamundani, I'm not so sure if you have something to say before we close this session.
Not really that much, but I just appreciate in terms of what has been covered in this session, especially understanding the statistical and computational thinking and the interrelationship between that, and especially looking at the visualization we're able to get from such languages as R. And I like the way the debate was also ensuing following this workshop. We hope this engagement will also continue behind the scenes. That's all from my side. Thank you very much, Dr. Wata, for such a session.
Thank you. Thank you. It's my pleasure. Thank you.
Dr. Chikohora, if there is nothing from your side, we may probably allow people to take a straight break so that we can resume at 15:05 when we are going to move to workshop number 3. Can Emily confirm if she is logged in?
Yes,
I can see she's logged in. So we'll come at 15:05 for workshop number 3. We can take a straight break, or probably we could say a commercial break. And Dr. Wata, you can continue also to engage with your participants via chat. I can see there's still some chat interaction there. Till then, let's meet at 15:05. It's exactly 3 Namibian time. And this is time for us to jump into workshop number 3. Welcome back to the last session of our workshop series for the 3rd IMITEC conference 2021. So far, we have had an opportunity to cover through workshop 1 and 2 before and after lunch. And this is the last session for the day in terms of our workshop series. You might have noticed, according to the program, that the title you've been having and also even the presenter might be different from what I'm displaying. This is the nice surprise we are having for this session, and I'm looking forward to this exciting topic. And we have Emily Undertop. I hope I'm pronouncing the surname correctly. You'll correct me on that. And she is going to take us through prototyping with Figma. I'm looking forward to this exciting workshop. And I will take the honor of briefly introducing our facilitator, Emily, in the few seconds from now. So Emily Undertop is a researcher from Aalborg University in Denmark. She holds a master's degree from Aalborg University in mediology with the specialization in interaction. Her work includes research within virtual reality, investigating this, the use of hand gestures, collaborating with the indigenous Sani people of Namibia and Namibia University of Science and Technology. Her research interests are within virtual reality, hand gestures, collaboration, cross-platforms, user experience design, and prototyping. There is none other than Emily to take us through this exciting workshop session. I leave the floor to Emily. Emily, the floor is yours.
Thank you so much. I would just like to confirm that you can hear me.
Yes, loud and clear.
Perfect. Then I will just share my presentation. One moment. Okay. Can you see my PowerPoint?
Yes, not yet in PowerPoint mode, but yes, we can see it.
Can you still see it?
Yes, we can see it.
Perfect. Good. Okay. So thank you for the very nice introduction. So as you already explained, I am Emily Arntorp. So you got it almost right, which is good. Yeah, so I'm here to have this presentation about Figma and what Figma is and how it's used. So in Denmark, it is used in the industry to make fast prototyping. So the designers quickly can make design ideas and show them to programmers. And you can even, at the end of this workshop, I hope you will be able to make your own prototypes. Yeah, so Figma is this very powerful tool that is web-based. So you don't need to install any applications, it's just in your browser. And you can use it to make wireframes, you know, these quickly done designs without any colors. Then you can go further into adding pictures, add colors, and you know, come up with something that you can see on the image here to the right, which is a fast prototype done in Figma. So of course you can also make this prototype function, so you can have buttons and connect them to different screens. And you can send your Figma application to participants. So even during COVID, you could still make tests, as you all you needed was this link. And hopefully all of you who's here will be able to do this once we're done with the workshop. Okay, so first of all, I would just like to give you a few minutes to make a Figma account. I think maybe 5 minutes. Or you could just let me know if you are done beforehand in the chat or something. So what you do is you go to figma.com and sign up for an account. You could use Google, or you can create with your email and password. I give you 2 minutes. If you run into any problems, feel free to ask me. I hope you managed to make the account. If not, stop me now, then I won't continue for a little while. Okay, we continue. So as soon as you have your account, this should be your front page where you have your recent draft and you can create new design profiles and already use Figma templates, but I will get back to this. So first, I would like to get you through this process of how working in Figma in an efficient way. So for instance, starting with wireframing, where you enter the design mode in Figma, I will show you later, from where you can input your design plan. So in this example, it will be a very small application for your phone for a bar or restaurant, so you can design the, so the user can find the name and how much it's rated, how far it's from you, a few pictures, and maybe some way of sorting which kind of restaurant you want. And this is made in Miro, which is also browser based, but I will not get much into that. So here I just planned out, so I have a start screen, I have my main screen, and then I have the actual details about the bar or the restaurant. Then I go further into Figma, where I, in this example, focused on the main screen, where in this wireframing, you design as many ideas as you can possibly think of, but without any colors or actual text, so you just use placeholders. So here's 2 different ideas for this bar example.
Sorry, Emily, are you sharing any screen that you are demonstrating on that? Or because we are only seeing the Figma workshop, Emily, and your name on the first page.
Really?
If it's a PowerPoint,
Okay.
it's not in slide mode.
Okay, I will try again and see if you can see it.
Okay, not a problem.
Okay. So can I ask you, can you see it now? Something
Yes,
else?
perfect. Now it's in slide mode.
Okay, good. So does that mean that none of you have made this account in Figma?
Personally, I've done so. I don't know about others.
Okay.
I've done
I
it.
will, sorry?
I'm following it also. I've created also.
Okay, perfect. Thank you so much. So this should be your front page, then I'll just quickly go through it again. So this should be the front page when you enter Figma, that you see this design, create new file or get a template. And then this was what I talked about with wireframing, about planning your design. So where the start is my start screen and choose bar is my my main screen from where I want all my information. And the last one was specific details about that specific bar. And now we're here, back again. Thank you so much for telling me. Yes, so this would be an example of the wireframe. So here I have two designs. This is the same design where I based it on a map for a location to find bars near you or restaurants near you, where you can click one of the locations and then this thing will pop up with the name, a picture, and how much it's rated. And the other one here to the right would have a little more detail. So again, the name, maybe a picture, rating, and then there could be either some buttons or more details here. So in Figma, you can make all of these shapes with icons, or you can make squares and buttons and everything. And we will go to that in the end. Yes. So the point of these wireframe is making these placeholders. So here I went with the example again, completely blank wireframe, where I filled it out with pictures and colors to actually fast make a design inside of Figma. And a nice way to do this is with something that is called components. I will again show you when we go into Figma a little bit later, where you can save those white templates and you can actually just drag and drop them into your actual design so you don't have to copy paste the entire time. And you can do this by organizing pages inside of Figma so you can have a very nice structure of your own design. For all of these pictures, you don't need to upload anything yourself if you can find it in one of these plugins, which is also a very nice feature of Figma because it contains both icons and images, and then of course you can choose all of these colors, and then the program can actually tell you if you don't have enough color contrast. You know, I think we've all seen people make white slides and put on yellow text and no one can ever read it. So Figma can also tell you if this contrast is high enough or not. So there's a lot of plugins. That's only go in, look what you want, and install whatever you need. Yes, and then of course you can prototype in Figma, as I briefly talked about. So up here you can see there's these tabs as design and prototype. And as soon as you enter prototype, you will be able to drag and point to which place you have to go when you make your design. So I don't know if you can see it, but this little button says go. And as soon as you press go from this login page, you will go to the main page of all of these bars and restaurants. As soon as you press this restaurant, you will go to more detail about it. And from here you can, it's all up to you and the design and the prototype, however you want it. A nice feature about this is that you can also choose how the pages are supposed to move in. In this image to the left, you can see that on tap, so by a press with your finger on the screen, it has to navigate to whatever screen this arrow is pointing to. And then you can decide if it has to move in from the left or the right, or come down from the top or up from the bottom. So there's all of these very, very nice features you can add to actually make your design feel more alive and be very, very nice to look at. So this is just a very, very short example of what some of the first year mediology students did in Aalborg. So this is the actual very, very first design they ever made. And I actually think it came up pretty nice, because you can see what they really are going for. Of course, it's a little bit in Danish here, but I hope you will manage. So this is a calendar for the new students, which they had to design to make their own lives easier as a new student at the university. So they thought of a lot of things of how you're supposed to see what day you are currently at and what day you have plans, and have a summary in the bottom of, okay, your next course is this day in this room. And then they also thought about all of the people who like dark mode. So they also designed to satisfy more users using the dark mode. So let's open Figma and I will see if I can share Figma instead. You can still see my screen. This time in something saying introduction to Figma.
Yes, okay.
Perfect, good. Okay, so this is where I want you to work too. So it's not just me talking, but also you learning to actually use Figma. So this is the example I based my presentation on. And then I would like all of you to actually try to make your own, so you feel that you can make a fast prototype as soon as we're done here. So let me know if it goes too fast or if I need to repeat anything at all. So if I go down here and pretend it's a new application, I want to press up here and add a new frame, which will be my screen. Then here on the right side, I will have the opportunity to ask what kind of application we're making. So I will just pick the iPhone 11. And as soon as I do that, it comes up here already in the correct size and dimensions as an iPhone 11 would have. Then of course you can do the thing you always can do when you copy and paste thing. Make sure you're up here in design mode. So you can create all of your buttons. So for instance, in this one, I know when working with iPhone, there's always this top bar where that would be my power and my internet connection. So I need at least this top bar to be somewhat empty. So to make these shapes, I can press up here with the square and make a rectangle. So we'll start by doing that. Put it up here. I'm still doing it all gray, so I don't spend much time on colors or anything. So right now it's just how it looks all visual with no colors. And then of course also in my button, I also don't really want to just have the screen end in nothing, because normal screens also have this small menu. So I will add another screen or another rectangle down here. You can always use shortcuts by pressing R or O for making a circle. Another thing I then want to make sure of is that this doesn't move as soon as I start prototyping. So I can press over here as fixed when scrolling. So it doesn't disappear as soon as I scroll down on my screen. And I also want this one to stay. Yep, when I'm scrolling. Now, where is it? Oh, well, you get the point. So if we take the example again of the bar, I would like another square here, which I would like to be my picture for my design of the bar. And then I know I want some text piece underneath. Just saying text, text, text. And it's very small, this text, so I would like to make it bigger, which I can also do over here from the side. So all of my visual details are over here. So if I just take base in what I know from Facebook or Instagram or anything, I would also like some icons, but I will get back to that later. So first of all, I'll just make sure that all of you know how to put up a frame and add some shapes and some text. I will also quickly make a round button just to make sure I have something round in here. So like this. Okay. So let's say that I really, really love this design. I know there's nothing in there, and we can agree it's not very pretty, but it can become pretty. So I don't want to duplicate this all of the time just because I want it further down on my screen. So if I just move this one and make my frame larger, so I can activate scrolling as soon as I've done prototyping. So something like this. Then I want this to repeat down, 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 but I don't want to just copy paste. And if I changed one thing here, I wanted to change it, all of it. So what I can do here is I select all of it, and then I can press up here on this small icon looking like 4 squares, which says create component. What that means is that it makes this kind of template. But to make sure it doesn't just stick in here in my application side, I can press over here to the side and make another page. So I already did that over here, but I will just do it again. So, okay, it has reached the limit. That's not very good. Okay, so at least I pressed the button here and I named it and I called it components. That means this is where I have all of my templates. You can structure everything as soon as you have these pages so you don't get lost in your own design. So as soon as I have made this component, I can right click it and say move to page, and then I can move it to my component site. Then it disappeared from here, but that means I can find it under my own assets. Here it is. Then I can drag it in, and I can drag it in again. And then let's say I don't want the middle button anymore. Then instead of clicking here all the time and deleting it, I can go into my component site, find my template, which is here, double click it, delete it, and then it will also be gone in here. I will give you a little bit of time to make some ideas for your own design. You can take base in this restaurant idea. So I will leave this page here for a little while, so you can start making some of these wireframes and get a little bit comfortable with making shapes and easy, fast designs in Figma. I think maybe 5 minutes is enough. If there's any question, feel free to ask.
Emily, you are muted.
Yes, that's because I gave you a few minutes to start on your own design in Figma. So you can ask me anything, or you can share your screen if you need me to see something.
Oh, perfect.
Yes. So I just gave this as an example on what you can work on. So you can start by, if you were to make a start screen for your own application, what would it contain? So would it be something of your area, or would it be changed language, or would it be some kind of login page? So this is just to somewhat get you started and get your hands into Figma instead of just me showing you everything. So it's a little bit learn by doing. Are there any questions so far? Okay. You can also tell me if you just want me to keep going, and then you can try it afterwards. But I just think there's a lot of stuff to learn, so that's why I take it bit by bit. the more prepared you are with your design idea now, the better it will look in the end. So add as much as you can think of for these design ideas. Okay, so I see the question in the chat, why I would recommend Figma instead of using something like Bubble. I actually don't know that one. Which allows you to make a build. Okay, so why I would recommend Figma is definitely because it's a very, it's a tool that's quite easy to learn. And it's very, very fast that you can come up with results. I must admit, I don't know this program Bubble, so I don't know if that's also equally fast. I don't know. But what I would say is really, really nice with Figma is that you can also collaborate more people. So for instance, in this page I have here, I can invite up to, I think, 5 group members where we can work at the same time on the same design, which makes it easy, for instance, to develop this prototype and give out different pages of the application and still keep the same theme of the design. So you can always see if I'm working on a start screen and someone else is working on the main screen, we can always see what each other are doing and compare if the design matches the entire way through. So if I go with the color of green and my partner goes with the color of yellow, it will be very, very fast to stop and have this conversation. And I also think it's very nice that instead of having to make an actual build, you can just send the link to whoever you want to see your design. So for instance, in this COVID times, it was not possible to have participants trying out your actual application just in front of you. So what you can do here is you can build it in the browser. And thank you for the link. So just send the link, and then the person can see your prototype on their own screen at home, and you can actually also still see what they're doing. So if I invite one of you to test my design through a link, I can see where you're pressing and where it would go wrong if anything goes wrong. I hope that answered some of your questions, and if you want to add details about Bubble, I'm happy to hear it. Is it also possible to share the design on Bubble? Okay, thank you. Is it possible to build in some functionality behind the actions? I'm not sure what you mean.
Emily, I think let's go through the presentation, then questions will be attended
Good.
to at the end.
We will do that. Then I also think you had a little bit of time to make your wireframes, so we will continue. Yes, so this was a wireframe I quickly made with you guys. So I just wanted to show you how fast you can make it into a better looking design. So for instance, this square up here, I don't want it to be just gray, but I want to put an image in there. And I want to use plugins to do this. So I mark my square, I right click, and then I have these plugins. All of these I have installed before this session, but you can always manage plugins or browse in the community. So if I press browse the community, it will open up a new page. And here you can search for instance, I had Iconify, which is really cool. And now I can't go back because of this thing up here. One moment. Okay, like this. Okay, so these are the plugins I have installed, and I can highly recommend Iconify, IMITEC, I don't know how to say it, and Stark. Stark is the one that allows you to check for color contrast, for instance. So if I open this image, I can search for what kind of image I want in my scene, and as long as I have this marked, I just press whatever image I would like, and boom, there it is. So it's a very nice tool to just fill in pictures, and you can search for whatever you want. So if I just say houses, it should be able to give me all different kinds of houses I can put into my design. Yes, okay. Then I can also use the plugins, as I said, to use icons, so you don't have to design all of them yourself. So again, I can search for a house, and then I get all of these different icons that I can use that I simply just drag into the scene. No, not now. One moment. So I don't have a mouse right now, so I'm using my mouse pad. Okay, so it's actually in the scene already. It's just teeny tiny. So it is here. Yes. And you can, of course, continue adding whatever you want inside of your design. So as soon as you know what features you need, for instance, the home button or a like button or anything, you can quickly easily add it into your design. Yes. Good. And then, for instance, up here, just to show you really fast how you can change colors in your application to make it match whatever you are doing as a design. You can do it with everything, your entire frame, or all of those squares and buttons you have created all through your design. So you just actually pick whatever you feel like looks nice. So I think it looks a little bit weird with this, but I think maybe toning it down would be a bit better. Oh well, you can always play around with this in your design. Yep. And again, with your buttons, if you have buttons, you can also select the button you want and again add more icons to them. I'll just take another house. But there's no limits on what you can do in your design. And of course, if you want all of this to change at the same time, you can go into your components instead of doing it the same every time. So for instance, these two, I don't want to change them all the time. I will just give them this really, really weird red color now, and they will be red already in here. Just ignore my colors for now. It's just examples. Cool. So if this had been a physical workshop, I would have went around and see what you've made. So it's a little bit difficult to see what you've done. But now I actually had some time for you to just play around with the design you already made. So make sure that you know how to fill in colors and add images. So I would definitely recommend you to install these plugins that I have here. Iconify, IMITEC, Stark. Unsplash had some problems, but definitely implement this in or add them to your system or your browser here. So instead of using time on this now, I guess I will just continue then. So let's say that now I want a different screen for this one to continue to. I will make a new frame of my iPhone. right here next to it. Oh. Yes. So right now it doesn't really matter that there's nothing on here. So if we move into prototyping, which is up here in the side, then you can start doing whatever you want. So if you press this button down here, not the icon, this one, you can drag it onto what screen you want it to go to. And here we have the thing about if it's on tap, on drag while hovering, whatever you want to do. Right now I'll keep it on tap, and then it has to navigate to this side and not change or overlay or anything. I just wanted to navigate it. I don't want it to be instant. I want to make some kind of smart animation or dissolve it. And then down here, it will show me a short image of how it will look like. Yes. You can also do like this, where it comes in from the side. Just quickly add a button over here, which will go back. I think we can actually even do like this. Then it automatically goes back to where we came from. And it's still on tap. Yes. Then what I can do is I can press play on my design. I hope you can still see that it's loading at least. I'm sorry for the internet connection. I'm staying at a hotel inside of Windhoek. There it is. Okay. So right now you can see it's actually, it doesn't really fit the screen, but I can slide side to side and I can slide up and down. Right now my problem is that I haven't fixed these icons to the screen when scrolling, but we can always fix that. What is really nice is that I can go directly into my design right now and make these changes, and this page will update automatically next to it. So if I press here, it went to the next screen. And you can see how this ease in and ease out is already implemented, which I think gives this nice touch. And this up here stays in place because I told it to. So this is basically what you do in Figma. And of course, I planned this as if there was any questions, or if you had, or if, while you were working, doing this this workshop. So I actually just have time for you now to work in Figma and ask any questions if you have anything.
Okay, thank you. Let me just check the chats if we've got any communication.
Yeah.
So far, we do not have any. Okay, the workshop is open for all participants who might want to ask, maybe who might have missed something.
Yeah, and also if any of you did something in Figma, I would like to see it, just to see if it makes sense or if you struggled with anything. If anyone would like to share.
Maybe you might share the participants. Is Figma is it an open software?
Yes, so it's just in the browser, so everyone can go into Figma.
You need not to subscribe anything.
Well, yes, you need to subscribe to be logged into Figma, but you can just do it with your Google account and it's free.
Okay. The account doesn't expire.
No.
Okay.
There's a small limitation sometimes if you don't pay for Figma. For instance, that I couldn't create another page. But if you are a professor or working at the university, you should be able to get that. So I don't even know why I don't have it, because I applied for it.
Okay.
Did anyone manage to make some kind of design in Figma? You don't have to show me. I'd just like to know if you managed to do something fast. Okay.
Okay, I see something on the text. I'm not so sure if you had responded to it, which says, so if I have a button, can I actually link it to actual functionality? Like, for example, a button to save data?
Well, you won't get data from the participant as if you are making a logging system, as in a Unity build or something. But you can make the buttons do something. So for instance, if you press go on this one, it will take you to a specific site that you decide. So it can go, from the start screen through the entire design. So in this one, there's only 3 screens, but you can go through all of them as a functional prototype.
Okay, maybe just follow up. I'm sure the person who asked wanted to know if this design can be further developed into a working system. Say maybe I've got my codes maybe in what? In HTML or maybe in Java, another programming language. How will I link these designs into my actual code?
Okay, so that makes sense. So you can actually press over here in inspect, where you can get code. So for instance, if you're making a website, you can ask for it to give you the CSS code, which is the overlay and the actual visuals inside of HTML. And you can get, of course, all of this information of what specific color you used. And in here you can see if you want some code for the iOS or for Android. So you can actually make your entire design here and test it before you even program it like hardcore. So it's a very easy program to just make a quick, fast design, go out and test it and see if there's any problems with the design already. And then you can change it inside Figma again, test it one more time and see if the problems from before are now fixed. And if they're fixed, then of course it would make sense to go into to a bit more hardcore coding. But then again, Figma can help you with some of the features for the coding. For instance, again, if it's a website, then it can give you the CSS code. So it's basically just a tool that you would need for your early design processes. So if I were in a group of 10 people, that's a lot, then it would make sense to have all of these wireframes and all of these idea generations from your project, and then discuss about these design ideas before you actually continue into some of the more finalized design. So it's actually just to save some time with having a lot of discussions where you miscommunicate or already implement something that doesn't work for a user. Because I think we all know this problem of having spent so much time on any kind of code, and then as soon as you test it with a real participant, they don't understand anything that's going on. So this program can save you some time doing that.
Okay. Thank you. I will check if there's a follow-up question to that.
Mm-hmm.
Okay, we seem to be fine here. Not sure if you want to proceed to other items or you want to.
Well, this workshop was mainly about Figma, but if there's any question about what I did in here in Namibia with the gesture study, you can also feel free to ask me about that, and anything you'd like to know about this VR gesture study, then I'm also up to answer any questions.
Okay, I think maybe what we can do is we can give our attendees time to work on it. So
Yes.
maybe what we can do is maybe you can furnish us with your details, maybe in the chat or somewhere else where you have them, so that the attendees can check the details and whatever they are working on. If they've got any challenges, they can reach you.
Yes, I would like that. So that was also the point, that you work a little bit on Figma and get comfortable with it. And if you run into any problems at all, then I am up for any questions. Or if you'd like to share an image of what you did, that would also be nice. So there were a few people in the beginning of the workshop who told me they made their account. Did they manage to make some of these simple shapes and add some colors and images? Or are you stuck somewhere?
I think they need more time.
Okay.
Okay, let me just check from the participants if anyone has managed to do anything that he or she may want to display. So you can get feedback from Emily. Okay, Emily.
Yeah.
Yeah, I think people would prefer maybe to work on their exercises maybe after hours, wherever they will be.
Okay.
Should I say maybe outside the workshop? So maybe we may give you this opportunity maybe to conclude and then furnish them with your details so that they can get in touch with you.
Yes, definitely. Should I share my email in the chat or something?
That would be good.
Good. There it is. I hope at least you got a little bit understanding of Figma and how it can be used. And if you are not a hardcore programmer, then this would be an ideal tool for you to work with.
Saying, thank you, Emily, for providing the email. So
You're welcome.
Attendees, you can check the email address for Emma on the chat. That is emna@create.aau.tk. So you can just check it from the chat. Continue working on the application and see what good things that can come out of this application. And then if you've got any issues that might arise while you're still working with this application, please reach Emily on this email. Maybe let me just give a minute to check if there's anyone who wants to say something before we conclude the session.
Yes.
Looks like we are all fine. Okay,
Good.
once again. Oh, okay, Dr. Wata's email. Okay, fine. Let me check if Dr. Wata is in to provide the email or is not in. Okay, fine. I'll certainly provide the email for Dr. Wata.
Okay. Then if there's nothing else, then I would just like to say thank you so much. And I hope.
Before I conclude, there's the end.
Yeah.
Dr. Stanley can come in.
Thank you, Dr. Chikora, and thank you to Emily. Emily, for a few minutes, I know this is not in line with what you are currently presenting, but it would be interesting to quickly share your research on those gestures that you mentioned earlier, so
yes,
that
definitely.
people who wants to collaborate with you. Thank you.
Okay. Then I will just find my slideshow because I have another one. And then one moment, I will find it. Okay. Can you see my screen now where it says UX workshop?
Yeah, I can see it.
Good. And you can still see it if I press this one. Then you can still see UX workshop.
Let me see. Press again.
Yeah, you can see why cultural design on a slide.
I can see your mouse. Not sure with others.
Okay.
I can see your mouse.
Can you see why cultural design
Oh,
now?
it's fine. No, it's fine.
Okay, good. Okay, so this is just briefly about what my master degree went all about and what I'm continue working on right now, and which is also one of the reasons why I'm back here in Namibia currently. So because I'm from Europe and I'm working with VR and hand gestures, that is because most gestures on these high industries are based on Western people, so people from America or Europe or anything like that. So that means there's very, very limited research about hand gestures inside of VR outside of Western countries. So I ended up going with this direction to challenge our own way of thinking back in Europe and to challenge some of those who developed these gestures. And then collaborating with the SAN community in Dongerbos, it would make it possible to generate new ideas, and they don't have this bias of knowing how to use VR. So let me just see here. So yeah, so I went into the bush with the SAN community where I had these gesture research sessions. So I kind of made a game for the SAN to play where they just use their hands to communicate. So something like charades. I think most of us knows the game charades. But this time, of course, they were only allowed to use their hands, so their gestures. So I asked them to solve different assignments. So the first one was, for instance, I had a drawing of a big square with a small square inside, and then I asked them to kind of draw it in the air with their hands. So you can see in the bottom picture, this man here, he just made a corner of a square with his hands. And I did all of this to make to compare them to a gesture research done in Europe to see if the gestures used in Europe are the same type which is used in Dongerbos. Then I had VR with me out into the bush where it is only possible to work if you are in the shade. So that's why we had this giant gazebo where you can see a lot from the community standing around looking at the one person inside of VR. I had them through a system called the Hand Physics Lab, which is something I did not make, but it is a VR system only making use of hands, where you have a table in front of you where you can grab and interact with all of the things you see in there just using your hands. So from this, the charades game and this Hand Physics Lab, I noted down how they use their hands. Of course, without telling them how to do anything. So I made sure that it was their own gestures and that had nothing to do with me or any of my research partners who went out there. And from this, I made my own prototype. Let me see if there's any images here. There's not. Okay. So I made a prototype in VR where I implemented 3 gestures, which I saw out there. So I saw the thumbs up gesture, which they used as a way of saying you are correct. This thing you did was good, so you can continue. And then they used a stop hand, so a flat hand pointing away from yourself to indicate someone to stop. And then I had a pointing gesture, which then came out to be this. I made this campsite inside of VR so they could design it themselves. So I added tents, fireplace, pots, a gazebo for them to move around in VR. So pressing a button would make it go away, but they could only make it stop moving by using the stop hand gesture. So after, I think I had, 25 participants for this session. And then afterwards, I have a whole co-design session with the community. So that included 4 participants, as you can see from this image. where at least one spoke English. So I made sure it was their own translators and their own words. So again, I did rely on someone who was outside of the community to truly understand what they wanted and what they felt was normal and natural inside of this VR system. Yes. And then there's this long video, but we don't want to see that. So yeah, I can see if I have some pictures of those gestures that I implemented. Is there any questions now while I look? No. Okay. Let me see. What you can see here, if I do like this. Can you then see a picture with some gestures, 6 pictures in total? I hope you can. We take it. So at least from these 3 pictures, you can see on the bottom left, there is a pointing gesture. And in front of them, there is a kind of TV where I displayed some of the traditional, what was it, perfume making in Dongabus, because what the community has previously stated is that they wanted something of themselves, you know, something traditional to be displayed inside of VR, because they really, really want to see some of their own culture represented in this digital VR world. And the reason for this design of the campsite is also because the Sand community would like to be more engaged in the surrounding world. So they have cleared this entire area on top of a hill to make a campsite. But for now, there's only just sand lying everywhere. So they had all of these plans of where they wanted a fireplace and they wanted the toilets and huts, and they wanted all of these things to make this a very, very nice campsite for people outside coming to visit. So to kind of give them an idea on how they could design it, that is why I made this system where they could place tents and fires and their own huts. And then they could move it around the way they wanted it to and completely design it as they wanted it. For a little extra fun, some of the Sand community expressed that after trying the hand physics lab with all of these different things in there, that they really, really like to see something they had never seen before. So just to make it a little bit weird, I implemented a robot, which is this round thing on the middle image in the bottom. So whenever they activated this, it would this round ball will pop up and be a robot, look around, and then it would pop back into being this round thing. So it was really, really amazing to see how they were so happy to see this robot, and the men found it super, super funny whenever the women thought it was a little bit scary. But all of them really had a good time, so you could see them smiling whenever anything happened. So it was truly an amazing experience. And having these 3 gestures implemented and talking with them afterwards to design new gestures has been super cool. And those gestures are now getting tested this time around in Namibia. You have questions?
Okay, thank you for that. Let me check if we have anything on the chats. Nothing at the moment. I think it's fine, Emily, you may maybe conclude.
Okay, then I would just like to say thank you so much for listening, and I hope some of you learned some Figma, or at least thought some of these gestures were interesting, as much as I think. Yeah, and thank you so much for allowing me to have this workshop.
Okay, thank you, Emily, once again for the time you took off your busy schedule in Namibia. I understand you've got a busy schedule that you are up to, but thank you for finding time to share with us on the things that you are working on. And I hope the participants that are logged in here, they will reach you, especially with the application that you were showing them on how to use it. Okay, let me take this opportunity to thank all the participants for joining the sessions from morning up to now. I can see there are quite a number of participants that joined in the morning, and they took all the whole day to be with us in this workshop. Right, so before I conclude, I just want to remind the participants that tomorrow we'll be meeting again in the same channel, the same login details, as we are going to be having the official opening for day 2. That is, for day 2, we'll be starting at 8:30 in the morning, but you can start testing your network and etc. from 8 o'clock. Our channel will be up. So 8:30 we'll be starting with the same credentials in the same Zoom channel, and we'll be having our breakaway sessions. You will be informed of the channels that you are going to be using for breakaway sessions. So with this, I say thank you and goodbye.